Hello, everybody. My name is Benjamin Chesser, and this is the overview of the Period 1 overview for Math 345, in case you're wondering. And this is going to be an overview of ancient mathematics. So the first slide, I want to cover ancient Egypt, and the context or the context of ancient Egypt. It's going to be around 3100 BC. That's when we first start getting some of the first records of the math taking place there, just a civilization. What is going on is they're preoccupied with surviving, I would say. Their life kind of depends on the flooding and the receding Nile and the crops that they harvest from the water from the Nile. And when they're not trying to survive via good crops and through wars, they're trying to survive under a tyrannical pharaoh, and also slave owners or slavery going on in those times. So it's a very hierarchical society where there's a lot of people on the bottom and very few people on the top, Pharaoh and kind of his peeps. And there was also an emphasis on pleasing Pharaoh. They kind of saw Pharaoh as like half god, half human, or some combination. So there was a big emphasis on building monuments and pleasing him and kind of doing whatever he wanted to. So I think that's kind of an interesting vantage point to look at it from. I would say that a lot of the contributions that ancient Egypt brings to us today is through their architecture. And I think, well, and there's a lot of geometry, a lot of mathematics that goes into their architecture. And so a lot of their advancements were actually done because of their need to survive or the necessity of their survival. They needed to be proficient in mathematics and geometry in order to please Pharaoh, in order to build him monuments to boost his ego or whatever Pharaoh had going on. The mathematics of ancient Egypt were done predominantly by scribes and government officials. There's not a lot of records that have lasted from this time period, but I would say that probably the average citizen of ancient Egypt wasn't going around doing mathematics. Like I said before, their main focus was on surviving and not dying in plagues, wars, and famines and whatnot. Their mathematics had an emphasis on applicability. So two of their mathematics was recorded on papyrus, which was a plant that is not really growing in the area today, but it was growing in the area in ancient Egypt. And two of the surviving, or not really surviving, but they're copies of the originals, or copies of the copies, are the Rhind papyrus and the Moscow papyrus. And the problems introduced in those papyruses show that the mathematics of that time had an emphasis on applicability, like I said. So the problems would be like how to evenly distribute food, how to predict the productivity of someone, of some laborer, and like taxes and such. That's what the mathematics was going on at the time. There might have been some, again, we don't really have too much of the resources from that time. There might have been some more theoretical calculations going on, but majority that we know of is just applicable mathematics. Let's see. The great contributions of the time, like I said, were the pyramids, architecture, and the temples of Luxor and Karnak. Next, and civilizations that were growing alongside or even before ancient Egypt, we had Mesopotamia, and then and that was Babylon. And similar math being done there, and emphasis on survival and kind of applicability in mathematics. So next culture is the ancient Greece. This was around 400 BC. And I think this is super interesting. Greece was kind of the first culture to put such an emphasis on play. They were the first culture to play and to have games. They had games for everything, competitions. They invented the Olympics. They had a democratic government. They were a direct democracy. And in this environment where kind of there's an emphasis put on the individual's accomplishments, the individual to contribute to political means and societal good through the democratic government, there was, an emphasis being put on individual accomplishment. So I think in this, under this structure, it really, we saw, we can observe an explosion of all different fields of science, like philosophy, mathematics, logic, and stuff. Again, they were the first culture to engage in play, so they didn't spend all their time merely surviving like ancient Egypt, Babylon, Mesopotamia. And they emphasized accomplishments of individuals. So it's in this culture that great historical giants like Euclid, Archimedes, Apollonius, Aristotle, Plato, we see them come to rise and make their observations and accomplishments in this period. Next slide. There was a belief of the world to be knowable, which boosted mathematical inquiry. Like the ancient Egyptians who depended on the Nile, they didn't really have a comprehension of why the Nile flooded and why it receded. But they were mainly superstitious and they prayed to gods of the Nile, the god of the Nile or goddess. But Greece, we see that they believed the world to be knowable, which boosted the mathematical inquiry happening in that time. So they saw it as like a problem that was able to be solved, not the Nile, but just other mathematical inquiries. So two people I would like to emphasize are Euclid and Archimedes. Euclid authored Euclid's Elements, which was used as a standard textbook well into the 20th century. The mathematics community was not the largest at the time, so we don't really know much about pre-Euclid mathematics too well, because once Euclid came along, made his observations, and people saw the brilliance of his observations, they kind of got rid of everything that was pre-Euclid. So we don't know too much of what mathematics pre-Euclid looked like for the most part. Euclid directly or indirectly influenced other figures like Plato and Archimedes. And Archimedes, Euclid's main accomplishment was Euclid's Elements and its contributions, like I said, well into the 20th century. Archimedes. Anybody who's taken a physics course has applied Archimedes' principle of a mathematical model. Now I included a picture of him with a lever lifting a large globe because that comes from one of his famous quotes saying if he had a lever large enough that he could move the world. But he really created the mathematical model, which in physics is kind of the exclusion of all the not important variables. Like if I threw a ball, like I'm not accounting for, it would be really hard to know how far that ball would go because I would have to count for, again, the pull of gravity. I would have to count for the wind, which direction it's blowing. I would have to count for the weather maybe. I know when it's hotter or when it's colder. So it just gets increasingly complicated to do simple real-life computations. Archimedes in the law of the lever, we see first introduced the idea of mathematical model, which is ignoring non-important elements of a problem and emphasizing and focusing on just the essential variables. He also used something that we still see in chemistry classes today, which is using the displacement of water to identify an object. And there's a really funny story. I'm not going to tell it right now, but there's a really funny story about how he found that out, taken a bath, and he saw when he got into the tub, the water rose a certain level equal to his mass. And so he he solved the problem. But he was, like I said, we still do that in chemistry class using the displacement of water that comes from submerging a certain object in order to know the identity of the material of that object. And then Apollonius, really quickly, he is best known for his works conics. So that is kind of an overview of ancient mathematics, and obviously there's a lot that is going unsaid, but that gives you a little feel of what ancient mathematics was like. So thank you so much for listening, and I love you guys. All right, bye.